Hi, this is Donna Warren again from the University of Wisconsin-Stevens Point, and I would like to talk a little bit more about argument mapping because this really is what I do for fun. Last time, I introduced the three ways that ideas can be related to each other in an argument. One way was one idea can be given as a reason to believe the other. So you just have two ideas, right? These are all relationships between two ideas. So one is being given as a reason to believe the other. The other relationship between two ideas is they might work together to support a third idea. The third relationship between ideas is that they're really not related to each other directly at all, but instead they each provide independent support for a third idea, right? They go separately. Today, I would like to talk in a little more detail about the first of those relationships because in many ways that's the most important one. So it looks like this. I have visual aids. Ta-da! Okay. What we have here, this is kind of a schematic for the diagram. This is the reason to believe this. So this is what we're going to call a conclusion. It's what we're trying to establish down here. This is what we're going to call a reason. It's the reason to believe that the conclusion is true. And this line in here is an inference. An inference is the relationship that holds between the idea or ideas up here and the idea down here when these ideas, there might be more than one up here, are given as a reason to believe this idea. There will always be only one down here. Now, I said last time that the orientation of this diagram doesn't make any difference, and it really doesn't. I tend to use this orientation with the conclusion on the bottom and the reason on the top. Many people do it like this, with the conclusion on the top and the reason on the bottom. Or you can also do it like, I know I used left and right wrong incorrectly last time, like this, where you have the conclusion over here and the reasons over here. Doesn't make any difference. Okay, so we're going to have it like this. Now, last time we used the following example. My neighbor is at home was the conclusion. The reason was the lights are on. Okay? So, we can represent this, or rather express it in a number of different ways using just normal prose. I can say, for example, the lights are on. This means that my neighbors are at home. I could say, the lights are on, so my neighbors are at home. I could say, the lights are on, therefore my neighbor is at home. This means that, the so, the therefore, all of those words are doing two things. First, they're kind of telling you where the inference is. So we can call them inference indicators. They're showing that that's the relationship between these ideas. Secondly, because they introduce the conclusion, when I say therefore my neighbor is at home, we can call them conclusion indicator expressions. So we have conclusion indicator expressions that are a kind of inference indicator expression, just like chocolate ice cream is a kind of ice cream. Okay? We can also express this idea in another way, this argument rather. We could say, my neighbor is at home because the lights are on, right? Where I'm giving this as a reason to believe this. So I know my neighbor is at home because the lights are on. I could also say, my neighbor is at home since the lights are on. I could say, my neighbor is at home after all the lights are on. Each of those expressions, because, since, words like that, they also say where the inference is. But they don't introduce the conclusion. They introduce the reason, right? If I say, my neighbor is at home because the lights are on, that's introducing the reason. So they are inference indicator expressions because they tell us this is where this inference is. And it says here comes a reason. It introduces a reason. So they're called reason indicator expressions. Now, the important thing to note here, I think, is that we've already seen a slight advantage to a diagram over normal prose, because I can express the relationship in prose in a couple of different ways. But the relationship itself is invariant. That never changes. If I use therefore, in some sense it's a more natural progression, right? Because I'm saying the lights are on, therefore my neighbor is at home. And what follows this is this, when I'm saying it or writing it in that way. But if I use because, can you see how that switches sort of the narrative order in the prose? I could say, my neighbor is at home because the lights are on. Look at what happens there. The narrative order is kind of the opposite of the logical order. In what I said or what I wrote, this idea followed this idea. I said this idea first, so this idea followed this idea. But in logic, I mean logically speaking, this idea follows from this idea, right? This idea is being given as a reason to believe this, so this idea follows from that. Okay, this is a big advantage to a diagram over text. This is sort of what I meant, one of the things I meant in our previous discussion when I said that text can somehow obscure the structure of an argument. That's just one simple way. Another way is, in prose, we might not say words like because or therefore at all. I could easily say, the lights are on. My neighbors are at home. I mean the same thing. I could also say, my neighbor's at home. The lights are on. I mean the same thing. I'm not using the word therefore. I'm not using the word because. There is no inference indicator expression, but the inference is still there. The inference doesn't go away. It's just unexpressed. In prose sometimes. In a diagram, it's always there. In a diagram, the inference is always that arrow, so we can always talk about it. Why is it important to talk about an inference? Well, it's important to talk about an inference because it's important to evaluate inferences, and it's very difficult to evaluate things that we can't see and discuss. So let's talk about how we would evaluate an argument, a little simple argument like this. Let's take a look at this thing. This is the reason, right? This is a special kind of reason. This is a premise. Premises are a kind of reason. What's the difference? A reason is always on the top of an arrow. It's always being given as a reason to believe another idea. That's why it's a reason. A premise doesn't have anything on top of it. It's being taken for granted. Later on, we might see subconclusions, which are both reasons and conclusions, because there's something else up here, giving us reasons to believe it. We're not going to do that right now. We can just say this is a premise. If we look at this premise, we might think, well, maybe the lights aren't on. Maybe what's going on is I'm seeing the reflection from the street light in my neighbor's window. So I'm mistaken in thinking that the lights are on. And if you know that this premise is false, and that means the entire argument isn't very good, because something that's false can't give us a reason to believe that something else is true. So, important fact number one, when we evaluate reasons, and certainly premises, it's important to ask, is it true? Now, there are other things that we can ask as well. It gets a lot more complicated than that. But just asking, is it true? Do you have good reason to think that it's true? That's the thing to ask about premises. Now, what if you think it's true and I think it's false, or vice versa? Oh, well, then we disagree. That's okay. I mean, understanding an argument and evaluating it doesn't necessarily mean that everyone's going to come to agreement. What it does mean, hopefully, is that we can isolate sources of disagreement, and that is profound. I mean, that's really of profound importance. The important thing, I think, it's great to agree. I don't like disagreement. I love to agree with people. I'm sort of conflict averse. But if there are disagreements, and there will be, it's at least nice to know where those disagreements are, what we're disagreeing about. So we might disagree about this. If I think it's true, good for me. If you think it's false, good for you. And if you think it's false, you think that the argument's probably bad for that reason. But now, let's suppose that I convince you that the lights are on, or you just decide, to not fight with me about it because I'm obtuse on this issue, you might also say to me, look, the fact that lights are on doesn't necessarily mean that your neighbor's at home. Maybe your neighbor has the lights on, some kind of a trigger system or on a timer so that they come on at a certain time. Okay, that's a good point. Now, where are you criticizing there? You're not criticizing the premise anymore, because you're saying, okay, fine, I grant you that. Suppose the lights are on. You're saying, even if that were true, this would not follow. You're criticizing the inference, right? It's that connection you're saying doesn't work. Here's how you can criticize an inference. Imagine that this is true and this is false. Oh, excuse me, strike that. Imagine that this is true. Ask yourself, could this be false nonetheless? Or, if someone happened to believe this, a rational person, would they be forced to believe this, right? So, would acceptance of this make acceptance of this significantly more likely? If so, that's a strong inference, because that's what inferences are supposed to do. They're supposed to be like truth funnels or acceptability funnels that take truth and acceptability in the premises and reasons and halves. It goes down there to the conclusion. Okay? Let me see. Okay, suppose that you finally convinced me that this is a bad argument. Does that mean that the conclusion is false? So you said, look, the lights aren't on. It's a reflection from the street lights. And even if they were on, it wouldn't mean that the conclusion, that this follows, because they could have their lights on a timer. So the premise and the inference are both bad. Does that mean that the argument is bad? Certainly yes. Does the fact that the argument is bad mean that the conclusion is false? Do we now know that in fact my neighbor is not at home? No. My neighbor could be at home anyway. The fact that an argument is bad does not mean that the conclusion is false. It just means that this argument hasn't proven it true. Similarly, if we hear somebody criticizing an argument, that does not mean that they think the conclusion is false. That just means that they think that the argument they're examining does not establish the truth of the conclusion. And sometimes the more attached we are to a given conclusion, the more jealous we are of the arguments. We want the arguments to be really good because we don't want a conclusion that we don't like to be saddled in a bad argument, right? What if an argument is good? We haven't really talked about good arguments now yet, but a good argument is you think the premise is true and you think the inference is strong. So in other words, you think someone who believes the premise would be more likely to believe the conclusion. Put those two things together. You believe the conclusion, you believe the premise. You think that people who believe the premise would be really well advised to believe the conclusion. Do you think you're going to believe the conclusion? I think so. So good arguments do establish the truth of the conclusion. Bad arguments tell us nothing about the conclusion. Nothing. Okay? So that's a little bit pretty fast about this I want to call it an elementary structure, but that can seem demeaning. It's the simplest, it's the atomically simplest argument that there is. That doesn't mean the content is necessarily easy. It doesn't mean that understanding them is easy all the time. But you can't get any smaller than this structurally and still be an argument. That's what I mean. The next thing I'd like to look at sometime is these dependent reasons. I haven't talked about that yet, but you've seen the argument, right? The one about the dog in the backyard. That's probably what we're going to talk about next. I hope my hands weren't in the camera too much. I'm sort of new to this. This was fun. Have a nice day. Bye-bye.